Okay, now, here's the deal. I heard somebody say logarithms are so hard. They do not have to be hard. But they are hard if we do not understand our exponents. Because exponents and logarithms overlap so much, and we're going to discover why as we go through. But if you understand how to handle your exponents, which by this point in your life you should, because you've been doing it since like 6th grade, then you should be okay. So we're going to start with some review work, just basic review of exponents. So I put some problems up here, and we're going to go through and do that. Does anybody see any problem up here that you can do, that you remember about? This is not a good omen. Hannah?
100 to the 1/2. Isn't that just the square root of 100?
That is the square root of 100. So the answer would be 10. Perfect. Fractional exponents are radicals. Fractional exponents are radicals. And the denominator of the exponent tells you what the index is, or what the, what radical you're taking. So square root, cube root, fourth root, whatever, the denominator tells you. So when I look at this problem right here, forget the 3 for a moment. What does that tell me? I'm taking the square root of 9. And then guess what I'm doing with it? I'm not timesing it by 3. I am cubing it. Look, if that weren't there, wouldn't that be 9 cubed? If that 3 weren't there, if that were a 1, that would be the square root of 9, right? So put those two together. This is the square root of 9 cubed. So the square root of 9 is 3, cubed is 27. All right, does anybody see anything else that you know how to do? Dan?
What under that, if it's negative, then you flip the...
This one?
Yeah.
When you raise something to a negative power, it gives you the reciprocal. So this is the same as 1/16 to the positive 3/2 power. Negative exponents flip you. So when you see a negative exponent, it becomes 1 over. Now, what does that mean, that 2 right there? Square root. So we're going to take the square root of 1/16. And then what are we going to do with it once we get it figured out? We're going to raise it to the 3rd power. So what's the square root of 1/16? 1/4. And 1/4 cubed is? I realized 3's in here 2 times.
164.
It's 1/64. That's right. This is 1/4 cubed, which is 1/64. So how do we handle negative exponents?
Put it under the 1.
Makes it 1 over. And then you have a positive 3/2. That means the square root cubed. This exponent means the square root cubed. Okay, so what's going on here? Same thing. So this is a negative exponent. Thank you, Rachel. This is a negative exponent. So what am I going to do?
1 over 8.
1 over 8. This becomes 1 over 8 to the 2/3 power. What does the 2/3 power mean?
3.
Cube root and then squared. So what's the cube root
1/2.
of 1/8? 1/2. And 1/2 squared is 1/4. So once again, you had a negative exponent. Make it positive. So 8 becomes 1/8 to the positive 2/3. The 2/3 power means the cube root squared. So what's going on down here? What does a negative exponent do?
Flip it to the top.
So this is going to become 1,000, just regular 1,000 to the 1/3. Remember, negative exponents give you the reciprocal. 8 became 1/8. 16 became 1/16. So what does 1/1000 become? 1,000. What does this mean? That 3 right there? The cube root. What's the cube root of 1,000? 10. What does that mean? So the first power. So that's just 10. All right, what about here?
You put it, turn 10 to the second. Oh, well.
First, it becomes 1/1000 to the 2/3 power. Kids, you got to take care of the negative first. You have to deal with the negative first. And what does the negative do? It makes it the reciprocal, makes the base the reciprocal. So instead of 1,000, it's now 1/1000. Now, what does 2/3 mean? What's that 3 mean right there? That means the cube root of 1/1000 squared. The denominator tells you which root you're taking. The numerator tells you what power you are taking it to. So what's the cube root of 1/1000? 110. Squared 1/100. Negative exponent. First thing you do is rewrite as the reciprocal. So what's this going to become? 10 squared. And 10 squared is 100. Step 1. See that? You're going to rewrite as a reciprocal. So that would be 2/3 to the 3rd. And 2/3 to the 3rd is 8/27. When you cube a fraction, you cube the top and the bottom. Right? Okay, before we do the next thing, I want you to get out your big packet. And we're going to do a little practice here. We've got all kinds. Remember, this one's stapled backwards, so we're looking at what would be the last page. And I want to start on the back side of that down at the bottom. So on the back side of that last page down at the bottom, where the first problem is 4 to the negative 1/2. Down at the bottom half of the back side of the back page. First problem is 4 to the negative 1/2. I want you to see if you can do those 6 problems down there right now on your own. Then we'll check them. See if you can do those 6 problems. The first one's 4 to the negative 1/2. 64 to the 2/3. 9/16. 3 to the negative 3/2. See if you can do those right now on your paper. Using these examples we just did as a model. If you get stuck. Okay, who, am I have these done yet? All right, Dan, are you confident with your answers? Could you put these up here for me, your answers? Trevor, do you feel confident with your
All of them?
answers? You're gonna put this column up, and then Trevor, can you put this column up? if you had like a step or two, why don't you go ahead and show it? Well, just in case somebody's got a question about how you do it.
Yeah.
Okay, what do you think about the boys' work? You think they, let's look at their answers. You guys probably can't see this, that's a 1/2 for the first one. Then a 16, and then a 64/27. And then a 1/100, an 8, and a 27. Anybody want to talk about any of those? Everybody in agreement? So everybody good. Now if you look in that packet, there's about 15 little half-page quizzes with exponent problems on it. What do you think's in your future?
Exponent quizzes.
Yeah. Okay? Now, if we have time at the end of the period, we'll do a couple more because none of ours have had letters in them. Some of the ones on some of those quizzes have letters, so we'll look at those if we can. But first, we have to talk about this problem right here, which is different. That problem says, the directions say, write the equation of the exponential function containing those points. And you will have a problem in your homework tonight, or 2 or 3 that are just like this, so pay attention. Now, have I ever given you points before and told you to write the equation of something?
Mm-hmm.
Yeah, we have linear equations, right? And you have a format for that. The format you have for linear equations is y equals mx plus b. All right, and you know what to do. Then a couple chapters ago or a couple sections ago, we had quadratic equations where I gave you the vertex and you were able to write an equation that looked something like this. Remember that? Those were quadratic. Those were our squared ones. Well, now we're doing exponentials. Exponentials are equations that have this format, and you know that because that was last night's homework. They gave you a few problems and said, are these exponentials? If they fit this format, they're an exponential. Notice, where's the x? Exponent. That's what makes it an exponential. So your job is to take those 2 points and figure out what the a and b are so that this new equation will contain those points. It's very simple. Always start with your intercept. You'll see why in a second. But always start with that point and simply plug it in. So 2 equals a times b to the 0. I took that point, put in y, put in x. Now, what about this?
Equals 1.
That's 1, because we all know that anything raised to the 0 power is 1. So what does that tell me about the a value in my equation? It's 2. So now I have y equals q to the x. Because a is 2. When I do an exponential, I'm always going to start with the point that has a 0 in it. because this magic happens.
Mhm.
Now guess what I'm going to do?
Plug it in.
I'm going to take the other point. 8/25 equals 2 times b squared. Put in 2 for x, 8/25 for y. Now I'm going to solve that. So the first thing I'm going to do is get rid of that 2. Because there's a fraction over here, instead of dividing by 2, I think it might be easier to multiply by 1/2. So b squared equals 4/25. Half of 8/25. 4/25. So what does b equal?
2/5.
2/5. Square root both sides. 2/5. So my equation is y equals 2 times 2/5 to the x. Do not ever, under any circumstances, multiply these two numbers together. They are separate entities. It is an a and a b. The b has an exponent. The a does not. Do not combine those, ever. Now, in your homework, they have presented the exact problem, but it looks a little different the way they wrote it. So look on page 286 at problem number 12. Because we don't want to have any confusion about this. We're on 286, problem number 12. Determine a formula for the exponential function. So in number 12, we are doing exactly what we just did. But number 12 refers to g of x. So when I look at the table they give me a table of values. I'm only looking at the x's and the g of x's for problem 12. So notice you have these points. You have way more points than you need.
You get to choose anyone.
You get to choose, but when you choose, you are absolutely going to choose that one, right? But then what other point you choose is completely up to you. You're going to start with this one. So 12 equals a times b to the 0th, which means what? A is 12. So your equation is y equals 12b to the x. Now, let's make our life easy. We can pick any point we want. Let's pick this one. Wouldn't that make life easiest? So y is 4. If b is 1, or x is 1, I mean, x is 1. So what does b work out to be? 1/3. Our answer, y equals 12 times 1/3 to the x. How many points do you need? Just 2. Just 2. So even though they gave you extra, do not be confused. Pick the 2 you need. 2 you want. Okay? Now, some other stuff in the homework. Take a look at number 15. This is review. This should not be an issue for you at all. Number 15 says, describe how to transform the graph of f onto the graph of g. Think back to your BFFs. What does the exponential look like? Do you remember? You know, lines are lines. You know, squares are parabolas. What are exponentials? Really? Like at the bottom it goes up. Exactly. That's exactly it. So right here is a picture of y equals 2 to the x. That's the problem they want me to sketch. Okay? Now, they said, how did you get this? You know. What have you done? Subtracted 3 from the x. What does that do to your picture?
Moves it
Moves it.
something 3.
Moves it 3 units. Which way?
All right.
It moves it 3 units
Down.
to the,
Left.
The right.
it's the opposite, so it moves it 3 units to the right. So it's gonna take every one of these points and move it over 3 units to the right. So every one of these points, and so we end up with a shape that looks like that. It just moves it 3 units to the right. Remember, whatever you do to x is the opposite of what you would think. So when it's x minus 3, it actually goes right. So you may need to refresh some of those rules, but this is the basic shape that you're starting with. So one more of those is number 26. Y equals 2 to the negative x. What does changing the sign on x do? Remember, this is the curve you're starting with right here. What does changing the sign on x do?
Flips it
Flips it. Which way does it flip it?
across the X.
Across the y-axis. When you change the sign on x, it flips you across the y-axis. So here's the original. So if I flip across the y-axis, won't I get this? Now, I'm going to caution you about something, okay? Because it'll get tricky. What if they ask you about 1/2 to the x? Then you need to be careful.
Go down 2 units.
What's another way of writing 1/2? 2 to what power? 2 to the negative first. Think about it for a minute. What does a negative exponent do? Turn you into your reciprocal, right? So wouldn't that be the same as 1/2? So what is this really the same as?
1/2.
2 to the negative x. When your base is less than 1, it means your exponent was negative. So that curve is going to be sketched exactly the same as this one. They are the same equation. So how would you sketch 1/3 to the x? What would that be sketched as? 3 to the negative x. Please keep that in mind when you hit some of those trickier ones. Okay? All right. Let's look now at, okay, the quiz the boys just did on the board. Let's just do the one above it. Let's see if we can simplify some of these. This is going to be no calculator work. So, especially when you look at something like this, you're thinking, oh, I'll just type that in on my calculator. No, you won't. So we need to figure this out without a calculator. Here's the first one, simplify. Any ideas? I heard somebody say 1/3x to the 4th. What do you think about that, kids? Whoever said it, I'm glad you said it, because it's the most common mistake I see.
Can't have an exponent on the bottom.
Oh, no, you can have exponents on the bottom. Exponents on the bottom are a problem. The problem is what, Will?
Just the whole thing before.
Actually, only the x is being raised to the negative 4th power. So should the 3 be moved? No. The 3 does not have a negative exponent. Only the x to the 4th does. So it should go to the bottom. It should become its reciprocal, 1/. It should go to the bottom. but only the things attached to negative exponents move. This is the same as the difference between this, kids, and this. Is there a difference between those two things?
Yeah.
This would mean the 3 also got the 4th. That's not what's happening in our problem. The 3 doesn't get the 4. Okay, is everybody okay with that? GTQ. This problem should take you 1 second to do,
What one?
but if you miss it, I'm going to write something on your paper. I don't know what. We're not going to miss this. Only the thing attached to the exponent is going to go to the bottom. All right. Now, what about this one? I've taken away your calculator. These would be huge numbers. If you evaluated these, they would be huge. You do not want to do that. What do you notice about all the numbers in the problem?
Divisible by 5.
They're all powers of 5. Not just divisible by 5, like 10 is divisible by 5, but they are powers of 5. 25 is 5 squared. So 25, I'm rewriting as 5 squared. Right? That's what 25 is? Times 5 squared. What's 125? 5 cubed. Now we're going to use some of those properties of exponents that you already know. What happens when you take 5 squared and cube it? So that would be 5 squared, 5 squared, 5 squared. How many 5s is that? 5 squared is 2 of them. Another 5 squared is 2 more. Another 5 squared is 2 more. So how many is this? 5 to the 6th. If you get confused, write it out. 5 squared times 5 squared times 5 squared. What have you got? 5 to the 6th. Times this 5 squared over what's down here? 5 cubed, 5 cubed, 5 cubed. That would be 5 to the 9th. Now, what do I have on the top? 5 to the what? 8. There's 6 of them and 2 more, so that's 5 to the 8th. Now, what's going to happen if you write out 5, 5, 5, 5, 5, 8 of those, and divide by 5, 5, 5, 5, 5, 9 of those? Aren't they all going to cancel? Except what? 1, where? In the bottom. So your answer is simply 1/5. So that mess reduces down to 1/5. What allowed us to do that? The fact that all of these numbers were powers of the same thing. So that's what you want to be on the lookout for. Okay, number 3. There is not a darn thing you can do to the top, but you need to do something with the bottom. So what do you think you might do with the bottom? Move it to the top. Kids, it has a negative exponent. Doesn't that mean it's going to shift places within the fraction? So you have your 2x to the 4th already up there, and now you're bringing up your 2x cubed, and there's nothing in the denominator now. This guy has a negative exponent, he went to the top. Do you understand why I moved the 2 this time also? It's in the parentheses with the exponent. John? Is it moving? Okay. Now, what about this? What does that become?
8x to the 3rd.
Very good. 8x to the 3rd. Everybody gets 8? Now, put it all together. What have you got? 16x to the 7th. Again, if you get confused about that, just think about it. This is x, 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 x. That's x, x, x. What have you got? X to the 7th. How about the next one, number 4? Everybody can do this one. What do we have in number 4? 4/3 squared. Everybody good with flipping it over? We're reciprocating it. So the answer would be 16/9. The next one. No calculator. I got 12 to the 5th over 6 to the 4th. How can I expect you to do this without a calculator? Well, what do you know about 12?
Divisible 6.
It's 2 times 6. So let's rewrite that 12 as 2 times 6. Now, see that 5 right there? Does that go with the 2 and the 6? Okay, so that would be 2 to the 5th, 6 to the 5th, over 6 to the 4th. Now, if I wrote that out, that would be 5 6s, right? And if I wrote this out, it would be 4 6s. What's going to happen to these 6s and these 6s? They're going to cancel and leave me with 1 6 on the top. Think about writing it out. Right? All these are going to cancel, and you've got one little guy on the top. What's 2 to the 5th?
64.
32 times 6.
190.
I can do that arithmetic without a calculator. That's the answer. And 6 is just a gimme. What's number 6? 1/8. Everybody good with 1/8? All right, any questions about last night's homework quickly? Anything in last night's homework that you needed to touch base on? All right, we'll have next point quiz on Monday. You got homework in your book tonight. Go team, your tests aren't graded.
They are?
They are not. Hopefully I'll get that done this weekend, get them online for you.